Today we're going to be talking about limits in continuity and complex analysis. This topic should be a bit old hat by now, but we're going to discuss a few strategies to overcome certain issues and problem types. The first problem we're going to deal with today is the limit of a fraction with a denominator going to 0. Okay, so we're going to be taking the limit as z goes to 2 of z to the power 4 minus 16 over z minus 2. Now, we're going to use a strategy of simplifying a numerator by factoring, which will hopefully cancel our denominator. So what's happening here? Well, z to the power 4 minus 16 is actually a difference of two squares. Don't let the fourth power throw you off. Z to the power 4 minus 16 is going to simplify as z squared minus 4 times z squared plus 4. Now we can simplify z squared minus 4 since it's also a difference of two squares. It's going to be z minus 2 times z plus 2. Substituting back, we get z minus 2 times z plus 2 times z squared plus 4. We can then use a z minus 2 term to cancel out the denominator. Okay, so moving on with the problem. Now, since we don't have a denominator anymore, we can just go ahead and take the limit. Plug in 2 for z. And now this becomes a really simple problem. And that's it. Okay, so now we're going to tackle a limit going to infinity. These are pretty straightforward, you just need to know how to handle them. Okay, so we're going to do the limit as z goes to infinity of z cubed plus I over z cubed minus I whole squared. We're then going to divide on the inside both numerator and denominator by z cubed. Of course, outside, since it's a whole square, and the outside would be z to the power 6. We then obtain 1 plus I over z cubed over 1 minus I over z cubed. And now notice I over z cubed when z goes to infinity is going to 0. So we're just left with 1 over 1 squared, which is 1. And that's it. We're going to move on to our third and final issue, which is arguably the most involved. We're going to show that a limit does not exist. We're going to show that the limit as z goes to -3 of the argument of z does not exist. To do this, we're going to show that the limit is different when approached from different directions. First, we'll consider approaching from the left and on the x-axis. Pay careful attention to the notation here. We're using a combination of right-left limit notation and normal multivariable limit notation. Now this limit is pi, since you go around pi radians. Secondly, we're going to consider approaching from x equals -3 and from the downward direction. Again, pay careful attention to this notation. Now this limit is pi over 2, since again you go around pi over 2 radians. Therefore, since the limits are different when approached from different directions, the limit does not exist.